Today we have Stephen Myers here to talk about WebAssembly. Everyone, welcome Stephen.
So I'm going to talk about WebAssembly today, and I think the 3 points I want to hit are the differences between how WebAssembly is executed in the browser, or the JavaScript engine, versus JavaScript itself, how WebAssembly and JavaScript can interact with each other, and what type of problems WebAssembly is trying to solve. So first, we're going to talk about just-in-time compilation for the JavaScript. So this is how JavaScript's executed in the browser. And the basic idea is you have your left-hand side. Yeah, that's the ignition, so that's the interpreter, right? So when JavaScript's first executed, it goes into that. And if the code path, or like the function or the line of code is executed enough times, because there's a monitoring mechanism, someone watching this whole process. If it's executed enough, it'll be optimized, right? And so like an optimization, and they could de-optimize if certain things break and stuff, but here I want to show you kind of what I'm talking about here. So, you know, the example of an optimization that can happen. Summing that array, right? In JavaScript, it's an untyped, or some people call it dynamically typed language, right? But there's no guarantee what type of each element is going to be. They could be a string, number, undefined, blah, 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 blah. But if the compiler, the engine watches and it sees every time it's an integer, it can generate code just for adding integers. So if there's many different types of things, a polymorphic kind of structure, then it's going to have to generate code. It'll say like, you know, if this is a string and this is a blah, blah, do this. And that's how you get those weird type coercion things where you try to add a string and number, you actually do get something. But so if it doesn't have to do that, knows they're all integers, it can generate like far less code, and that means it's going to run faster, right? So that's, and lots of the optimizations, this monomorphism, however you pronounce that, is probably one of the main types of optimizations you'll see like online when you try and figure out what's going on. So I think it's probably one of the upper, or the ones they hit the most, but there's undoubtedly like smaller types of optimizations that can be made as well, right? So, and now this is the difference, right? Because over here you have like the JavaScript coming in, it has to go through those code stub assemblers, it has to be monitored, it has to be watched. WebAssembly doesn't have to do that, right? WebAssembly is already typed, like it's already compiled, right? And it's just going to run through and go right in there. So it's already going as quick as it possibly can, basically. Because the other path is, you know, go through there, you get interpreted, you generate some bytecode, and eventually feed it through the optimizing compiler again, come in here, right? So WebAssembly comes in quick, it comes in hot, it doesn't need to be parsed, because like the JavaScript itself too, you're going to have to parse all the JavaScript before you can even start running it, right? And that's what's going to, then you can generate all your code. So generates quicker code, right? And then, okay, so assembly, right? You know, assembly in general is a very terse language. Like no one writes by hand. There's probably like, you know, well, some super geniuses working on operating systems or something, maybe they write it by hand, but normal humans, we don't. And so here's like an example. This is like simple, right? This is like a print, just print string. I forget what type of assembly this is. And that's the other thing too, assembly itself, it depends, you can't just run assembly on any machine. It has to be an assembly language targeted towards the architecture. So when I'm talking about like up here, down here you see Intel, ARM, PowerPC, MIPS. So it has to generate different types of assembly, right? So WebAssembly though, it is like it has like instruction set like assembly, but it's a virtual instruction set architecture, meaning you're going to have an instruction, like for example, let's just say move. I'm pretty sure everyone has move, but whatever. And then depending on what type of machine it's on, it'll know what actual assembly it has to generate, right? So that's a big thing. Some people are like, they love that part about it, you know. And okay, so now we'll talk about Asm.js, right? Asm.js kind of fallen off in the limelight. You know, it doesn't have as much fanfare, but it's like firstly like widely adopted solution for compiling your C code to run in the browser. It doesn't require a plugin. Google and stuff, they had like native client and some other types of things were invented in the past, which allowed you to run like native code in the browser, but the user would have to opt in, download a plugin. This is just JavaScript. You can run it. If the engine doesn't support it or whatever, it's just going to fall back to JavaScript, and it's fine, right? And it's still very relevant. The main way to compile, or the recommended way to compile your C code to a WebAssembly today involves first compiling, like there's a tool chain that's abstracted away from you. But first thing it's involved is turning into Asm.js, and from there it turns into WebAssembly. And the Chrome actually will take Asm.js and turn it into WebAssembly itself. So you could write, so you get those benefits, WebAssembly, right from Asm.js and Chrome. today if you have a new browser. Yeah, you know, so it's just JavaScript. Using array buffer. I want to say I said to mock the heap, but really it uses an array buffer as a heap. So that's kind of, I thought that was kind of cool. And here's an example. Like this is a SQLite function, and like I saw lots of examples for this, and they would have like two numbers added together, and you'd be like, okay, well that's great. I can just write this by hand. This one's like the middle ground, but I think it gives you a hint that it's not really meant for you to be written, like to write this by hand. And then if you look at something like malloc or something, it's just like an unintelligible garbage of like dollar signs, and you'll never get it, right? But I mean, like this you might be able to, but you're not supposed to. And then so you over here, right? This is how you get the 16 or 0 basically, or bitwise OR. That's basically casting it as an integer. And you could do there's other ones with little plus signs and stuff. So they got return type annotations built into it, right? And that's what your JavaScript engine will use to build the compiled code. Okay, so downsides. You know, if you have a big application and you're going to like compile it to Asm.js, and it can generate megabytes of JavaScript, like you have to parse that and stuff, and that goes against the whole. I'll get to it a little bit later, but that's a significant downside because that increases your startup time and whatnot, right? And then you can't extend it. It's JavaScript. Like let's say you want to add threads, you can't add threads to JavaScript. Well, unless it gets adopted into like JavaScript as a whole, but you can't add threads to just Asm.js because it's a subset of JavaScript, right? And yeah, so that was a real kind of issue with it, right? But people have built like some really cool stuff related to Asm.js, like even like a SQLite, you can compile that to Asm.js, and oh man, like game engines, a whole bunch of stuff. It's really cool. Okay, so WebAssembly. Now, the main part, so that's Alan Zakai, I'm probably butchering his name, but he's the guy that built and scripted. He's the guy that first came up with Asm.js. He's pretty much the godfather of this site. Well, I don't know, maybe that's being a little overly generous, but he's real smart, real good guy to listen to. And he's talking about the main job is to start large applications quickly. It's not like, I don't know, this almost got me frustrated enough to start like learning about this, because every forum I go to, there'd be so many people saying, well, I'm going to write C# and I'm going to write Ruby in like 4 months because WebAssembly's here. No, you're not, man. You're not. That's not going to happen. Give it up. Like someday it might, but even Benedict Mueller, who's like the head of VA, here's a kind of an interesting conversation they were having, where some people were talking about compiling TypeScript to WebAssembly, and you can kind of fill in the details. But I think the most important parts to look at are like number 3, you know, number type. If you're missing that in WASM, you have to build up the whole thing. Because lots of these languages rely on their interpreters and their internal structure. You're not going to be able to copy over, like, I guess maybe if you compile the whole JVM to WebAssembly and route it in there, you might be able to do it, right? But you can't use the idea that you're just going to compile Java and just run in this, or compile like Python, just run in this. The languages are very intertwined with their interpreters and their virtual machines themselves. And then, yeah, so missing GC, people say, well, once you get a garbage collector in WebAssembly, we're going to be able to plug in any other language. But no, you can't. It's not quite like that. And if you want to learn more about that, you can go to the Golang issue tracker for WebAssembly, and they have a discussion about how they're trying to bring their, you know, they're trying to port to WebAssembly, and they're talking about how they changed their garbage collection semantics to fit it. Because Go is a pretty good target for WebAssembly actually, because it compiles the entire runtime down to an executable, so you get like a 2 megabyte hello world. But you could theoretically compile that a little bit easier because you don't have this virtual machine that you're leaving behind, right? And there are other languages that have been ported. Lua, like quite recently, they have a WebAssembly implementation, but that again, that makes sense, right? Because that's typically a hosted scripting language for C. So like these languages that aren't going to depend on a bunch of stuff, or as he puts it, don't need a lot of magic. Those are the types of languages you're going to see in WebAssembly. You know what I mean? And like I'm not exactly sure it means the types of magic, because like you got C++ and like it's got tons of magic in there, but I guess he means something else. Okay, so this is just saying this. I just want to show that WebAssembly, when you get it, it's in binary, right? It's but you can transform it into this textual representation, right? So this is kind of like right-click view source in a way, right? So it's readable. It looks like a Lisp. It's not a Lisp. And the cool thing about it here, right? So you're importing a function. This is basically going to be coming from JavaScript, okay? And then you got an exported function. That's your C or your C++ or whatever, right? And then so we're just going to take our we're going to call our imported function with 42 is like the argument, right? So and then you got typings I32, I32 comments, blah, 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 right? It's relatively straightforward. I'm sure if you actually looked like at a real function, it would get out of hand pretty quickly. Yeah, so here, this is how we're going to hit the execute button, we're going to execute this code, right? So you have your import object, and so that's your JavaScript, right? So this WebAssembly module is really a combination of your native code and your JavaScript, and they're like married together. Well, not married together, because you can have one without the other, but, well, you could omit the JavaScript part. And, but you can see how this is it's going to work into making an API. You're going to make, I think what's going to happen is you're going to have your C and your C++ or whatever, and then you're going to have your JavaScript API over top of it. And yeah, so like, this is like not really very impressive, right? But you're just going to have a 42, right? So, but what's cool is we're calling WebAssembly from JavaScript, right? So that's kind of cool. And it's down. Okay, here's this link. This is strange. Well, here, I'll show it to you first, right? So some guy did this digital signal processing kind of stuff, right? And it's not rendering. Why is it not rendering? Well, that's a kick in the nuts. This was working like, maybe I'll just refresh it. Okay, there we go. All right. So here you can look at this, right? And you can kind of see where WebAssembly is quicker, right? But the interesting thing is I ran this on my browser and on my desktop at home, and I was getting numbers that were like WebAssembly was like 1,000 times faster, 700% faster. And then today I updated this to Chrome Dev. So I think in the past, like, I don't know, a couple iterations of Chrome, they've like matched the JavaScript engine, because these numbers are like far more comparable. And you look at some of them, they'll be down near even. Sometimes the JavaScript, yeah, this one's, oh no. Yeah, they're very close. Anyways, but it's kind of a cool idea. It was more impressive when the WebAssembly was kicking JavaScript's ass, and then you can kind of look at it and be like, wow, that's what WebAssembly is used for. Now they kind of came a little closer. Okay, and then the next thing, why are you not doing, what's going on here? Or did I lose Wi-Fi or something? No. Yeah, you're not. Here, let's go to, or maybe it's in. Yeah, I know you're unresponsive. Go away. And once this starts, I'll just continue the presentation from where we were at. There we go. All right, where were we? Okay, how to try. I think is that where we're at? Yeah, that's where we're at. Okay, so Mscripton, you just go there and you're going to download their SDK, and it's a little shell package, and it you could do stuff like, you know, install latest, install whatever, right? So it's very, very familiar to what you should be used to, and it'll install the whole tool chain. And there's like multiple compilers. There's a Clang, and there's this, there's that. So without that help, it might be a pain in the butt. And be prepared though; it's going to take a while to compile, because C takes forever to do anything. Well, no, it takes a while to compile. And then, okay, so the compiler itself, it feels just like, you know, GCC. You get a.out.js, so that's very familiar. And then actually, for lots of their projects, they have like, so C, sometimes you'll do like a /configure and then like, or whatever, and then make. And then you basically just wrap that in your EMCC, and it should take care of all that for you. And it seemed to do it for me. You know, like, to be honest, I tried to, okay, and then you can also make a generate HTML or run your WebAssembly for you. You're not gonna do that for production, but just demoing something is real cool. And then, yeah, so that configure and that make stuff, it seemed to work, but I had problems like with larger libraries. Like sometimes I just try to like compile like some like test rec, like an OCR library, just to see if like you can do it. And you need to know a little bit. You need to know a little bit about the build systems for C++ and stuff like that. Like I had to change like file pointers inside my Linux, and you have to go to some prof's like website from 10 years ago to download this library. It sucks, right? And then so then there's a SQLite. Tried to port that because it was like ASM. It compiled to ASM.js, and I was like, oh, I could just compile it to ASM, right? And you can, but like so those libraries though, they might have APIs that are designed for ASM.js. Like I ran into a problem where the API seemed to rely on that heap, right? But there's an actual heap in WebAssembly. There's no like array buffer. So that was kind of a kick in the nuts. But and then so sometimes you'll compile your thing like this is probably hopefully it's gone away. But sometimes you'll compile and it'll be like a previous version than the one in your browser, or like Node, for example, the Node latest a couple weeks ago didn't recognize the MVP, the minimal viable product version of WebAssembly, and then the advice I got was to just wait. So hopefully that's cleared up. But if you do get mismatches, I would say now I would just like update your browser and then update EMCC and just go to town, because I bet they're probably figured out right now, hopefully. And then I got like, if you do end up going over here, these are the talks I thought were good, the articles, and then like the threads. I like reading the threads sometimes because you get good conversation between people that seem to know what they're talking about, and it'll be different than the official word coming down from on top. And that's everything. Does anyone have a question? Yeah, go ahead.
So, is WebAssembly bundling your code in a more machine-readable way? So is it actually amplifying the code, and does it in a more efficient way for the code?
Well, okay, so WebAssembly, maybe like the point of that, you want to take native code, right? And you want to run it in the browser. You can't do that, right? So you compile it to WebAssembly, and then that your browser can read, right? So it's more efficient in that it's like it's really one of the only two alternatives. The other alternative is ASM.js, and yes, WebAssembly is more efficient than that one. Does that kind of answer your question, or is that?
It's just bytecode, right? It's just bytecode.
Yeah. It is bytecode.
But I still download the JS file.
No, there's no JS file at all. You take your C program. Let's say you take SQLite, like a nice little database. You want to run it in the browser. You compile that to WebAssembly, and then you run that WASM thing. The JavaScript part you might have would be like some type of API over top of the WebAssembly, right? So maybe you'll have something like, imagine this is more involved, and you had you had like your that simple.wasm was like SQLite.wasm, and then import object. You'd have stuff like maybe you have like find post or something like that, or find that, and that'd be the JavaScript, just an API operator on top of that. So they're two different concepts.
Like I know a big part of your JavaScript startup time is in like a browser is actually going through and loading all the JavaScript and then parsing it and turning it into something that can run into VM. So one of the big things with WebAssembly is like that is a lot more optimized. Like the format itself is meant to make that fast and efficient to get it from WebAssembly into code.
Right. Well, it's already going to be parsed, and that's the other thing about too is that what you might be seeing, and like they talked about this, is maybe you might be seeing parts of your framework that stuff like, let's say like change detection in Angular, or like the reconciliation algorithm in React, stuff like this. They might move that to WebAssembly, so that takes out less JavaScript to parse, and it runs ideally quicker. But I mean, as we saw from the last example, who knows? JavaScript might just take over the world, right?
I think maybe the important clarification too is, like, for those who didn't see the WebAssembly talk before, WebAssembly is like a new, for lack of a better word, like language, like that's a sibling to JavaScript that is like executable by the browser like natively. So it's not like getting transformed into JavaScript and then the JavaScript is executing the code, but it's actual bytecode that the browser is able to consume just on its own. It doesn't need to go through. But JavaScript and WebAssembly are able to talk, so you can outsource a lot of the heavy lifting to WebAssembly potentially.
So do you mean that WebAssembly running inside another virtual machine?
Nope. So
It's the
WebAssembly,
same virtual machine?
yeah, it's going to run right through here, right? It'll pass through, scheduler, control flow, and then it generates the code.
Yeah.
So it's running inside. And then the thing about it too is you're going to be able to like run this. You can run it in Node. They want to make it with POSIX compliant operating systems. So that's the other thing about this. It's really cool, right? A lot of people get stuck up on this I don't know, the other language thing, which kind of bothers me. But the thing about it is like, how long have being computer science people are looking for this write once, run anywhere thing? You know, people have been doing that with Java. This is like the next iteration of that. Who knows if it'll stick? I mean, you know, time will tell. But this very might well be the thing that you could write once, or you know, you write your C and you compile it once, and then you just run it anywhere. You can't just compile C and run it anywhere now. Like, good luck, you'll kill yourself.
You mentioned that's no garbage collection. What do you mean?
Well, no. Okay, so it has no garbage collector right now.
Right now?
Right now they want to have a garbage collector, right? But so it's like in C, you have to you have manual memory management, right? You have to free it. You're gonna have to, you know, the malloc and stuff like that. And so a lot of people though, they have this idea that once they do implement a garbage collector, they're going to be able to take their favorite garbage collector language X, you know, like I don't know, Python or whatever, and just bring it in. But they're not the, so you can't just plug and play these things. And if you want to look at like a good discussion, the Golang discussion thread is really good for that. It's short, but you do get the idea that they're saying, oh, this is how the garbage collector is implemented in WebAssembly. We want ours to work like this. How are we going to do that, right?
So do you mean that WebAssembly will have a garbage collector in the future?
It should. That's what they want to do. And once they do that, then they're going to hopefully they'll be able to access the DOM. You can't access the DOM right now, right? Because but once we get the garbage collector, we should hopefully be able to. Yeah.
I think it was Tim Berners-Lee was on a podcast talking about it, and they were saying that they were looking at like the .NET Common Language Runtime and garbage collector in that. Something where it was like a common garbage collector that a bunch of languages would use, and so it would be something like that. But yeah, it's something like that's still a ways from happening.
I don't know. You know, that is a ways from happening. It's kind of like the design docs had a little picture of the unicorn beside it. And but it's interesting though, because they can hack and use threads too. You get these discussions where people are talking about these garbage collections. And one thing about the CLR and the Java thing they were saying is that perhaps, I don't know exactly this, but those garbage collection, like those runtimes might be so intertwined with the VM, they might have so much reflection, so much semantics tied down to that it might be very hard to port them. So you might not you might never see like this thing where you're just going to run any language you want in the browser, which I think a lot of people is going to be just mind by.
Well, that's one of the big differences. Like, and I think why this has been successful in a way that like Dart, like native client, like portable stuff like that, is that those were both separate VMs that ran in parallel with like the JavaScript VM. Whereas like this is plugging right into the JavaScript VM. So basically, like once it's executing, it's almost like it's the same code running in the same VM. Or just whether it's through JavaScript.
And I was gonna say something I forgot. Okay. All right. Thanks, guys.
Can I just
sorry. Yes.
one more question about this whole idea of the two types of code talking to each other? Is there, like, when you're writing your C code, is there a specific WebAssembly API that you declare what you're going to expose to the global environment, or is it just your C environment globals become your JavaScript environment globals? How do they talk together?
There's like that is tricky, you know what I mean? And that, like, from what I understand, it's just like that code that I took over there. That was already compiled WebAssembly, so I didn't write the C for that. So that's why I'm not exactly sure about this. But I have seen stuff where there's like this extern kind of directive, so it's like an external function, and then there's also the inscription itself has like multiple headers. So I wouldn't be surprised if there's some of that functionality built in there. But that's a good question.
So that when you compile it, you do a sort of import these functions or these globals.
Yeah, because if you look at the at this function, right, there is that imported, like it knows about this imported function, right? So that was compiled from C. So C does have this import thing. I don't know exactly how it's going to work, but.
But I think some of that ties in, like the spec is kind of in a weird place right now because the spec isn't like finalized, but the browser vendors have said basically that they don't want to finalize the spec until they actually get the production data of people running it, which is why they've all kind of released it right now, is because they want people to start using it. They can get some, I think, feedback about things like that, and then tie it back into the spec so they can release it eventually.
Yeah, no, that's a part of it that I didn't realize, that you'd be able to create a WebAssembly core, which then has a JavaScript API that you can write a layer on top.
And that's why I think a lot of people, they kind of have to say, like, is this going to kill JavaScript or something? But I mean, even if you look at it right here, like they're already like they're like married at birth almost, right? And if anything, like Luke Wagner, he was talking about how it could solidify JavaScript as the scripting language, right? So, and I mean, he's pretty smart, so I take his word for it a little bit.
When you also probably wouldn't want to write WebAssembly by hand. Like a lot of it, like unless you enjoy writing assembly code, like
No, I don't think
most
I
people
would.
are going to want to write JavaScript.
Yeah.
But you could write in any language theoretically and compile to WebAssembly. I mean,
Yeah.
You can do that with JavaScript, but you don't get a lot of these advantages. So.
Yeah.
Yeah, and there's like, I mean, that Benedict Demure tweet thread kind of like talks about like the cause of compiling JavaScript and WebAssembly. And I think a lot of people, Luke Wagner was talking about too, is like the JavaScript runtime. It has a lot of information about like the engine, like it knows about the environment it's in. It can optimize for that, right? If you just compile that to static code, you're gonna lose out on lots of the benefits. So
But it's a matter of knowing what a language is good for, and there are some things that aren't good in JavaScript because of the dynamic typing and anything where you're doing lots of numerical computation.
Sure.
It'll be a lot of advantage to go into WebAssembly, like the video editing function where
Yeah.
it's, manipulating huge arrays of numbers. You want that to be optimized.
Can I ask you, what doesn't it have access to right now? Like, I know you can access the DOM, right?
Can't access the DOM. That's like some of the web APIs. I don't think you really have access to. Like, I don't think you're going to be able to say like, give me the webcam or whatever, right? But like that is going to change, and there is this kind of wall right now between JavaScript and like I guess I think it's ASM.js too. But anyways, WebAssembly for sure. And there's like the message passing that gives a lot of context shifting and stuff like that. So you lose speed, but that's going to be gone eventually too, hopefully. And then you'll just be able to write like your real performant code in like C, C++. And the other thing, it opens up whole new avenues. I mean, like ideally, like let's go run wild and like be the optimistic and say you're running entire AAA games inside the browser, right? I mean, if they start doing that, like JavaScript developers, I mean, someone's gonna have to write the UI for everything outside the game. So it really could bode well for us, hopefully, maybe.
We're pretty getting close on time. Maybe
Yeah.
one more question at most. But okay, might be good. All right, thank you.
Thanks, guys.